Hello viewers, we are going to still look at center of gravity, and under center of gravity we are going to consider circular lamina and a square hole, the situation whereby you have a circle and there is a square hole cut out from the circle. And so the question is, a square hole is punched out of a circular lamina. This is a hole, it has been punched out, being the radius of the circle as shown in figure 1. Find the center of gravity of the remainder if r is the radius of the circle. So this we are not given numerical values to solve it, but we are asked to find the center of gravity. So now let's look at it. The circle and the square, they are plane shapes. So if we are finding the center of gravity, we are going to consider their areas because they are plane shapes. So the first, we have to call this one, and then we call the square hole 2. And so we have to consider the circle. So for the circle, we have that area A1, because we are considering it as 1. A1 of the circle is pi r squared. Okay, we are not given value, so we just solve it that way. We've gotten the area. And again, note, if you look at, the shape, it is symmetrical. The shape is symmetrical about x-axis. That is, if you cut it up, if you cut it at the middle, you are going to have equal halves up and down. But if you cut it this way, you're not going to have the same shape, because if you cut it in the y axis, we are going to have a hole here and there will be no hole here, so it's not the same. But if you cut it in the x axis, you are going to have part of the hole here and then part of the hole here, so like a mirror of the other part. So that is why we are saying that this shape or this combination is symmetrical about the x axis, because if you cut it in this direction, in the x direction, you are going to have the same thing. So since it is symmetrical about x, we are going to be calculating just for x and not y. We are not going to consider y. So the x1 here for the circle, x1 is going to be, we know that for the circle, x1 is going to be d over 2. That's the formula, is d over 2. So that's diameter over 2, and that will give us r, because d over 2 is equal to r, or d, if you cross multiply, you have that d equal to 2r, or d over 2 equal to r. So that is it. So our x1 for the circle is r, because it's d over 2. Okay, now for the square hole, for the square hole. Okay, now we are going to do something for the area. The area for the square hole A2 will be, okay, let's calculate this using Pythagorean's theorem. Now this is a square, and we know that if I bring this out, this is what we have. If I bring it out from the circle, okay, if I bring it out from the circle, this is what we have. And this diagonal is here. Is here. So if I decide to break it out and draw it like a right angle triangle, I can draw it like this is L, 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 and this is our R, which is the radius. So if I bring it out, if I take this out, if I decide to take this part, okay, let me take this part the way it is, this, and this. So this will be L, this will be L, and this will be R. So we can use Pythagorean's theorem to determine what will be the area of this square. And so from Pythagoras' theorem, we'll have that this R square will be equal to L squared plus L squared. And so L square here will be equal to L square plus L square will give us 2L square. Because we are looking for this L, we are looking for L square, which represents the area of this square shape. So we are going to divide both sides by 2. So when we divide both sides by 2, divide both sides here by 2, both sides here by 2, we cancel out. So that our L square will be equal to R square over 2. So this is now the area of the square. So the area A2 of the square will be R square over 2. Okay? And now let's find the x, the centroid x2 of the square hole. This is the square hole. So we do the same thing now. Not the same thing. Now, we know that from here down, I've showed my videos, I've shown how to find, x. This is the x-axis. So we are considering everything from here down to this point is the x-axis. Now first we have to consider this. Now from here down to here is the first r we are going to consider. So this will be r. Okay, let me take it up there so that I can have space for the calculation. So we take our x2. So our first radius is from here down to this point. This is our first r. That is before the square hole. So we have the r plus. Now this other one that has to do with the square hole, we are going to do r over 2, because for a square it is d over 2. Okay, so that's why we are doing r over 2. So the d is the length. So if we work out this, we are going to have, if we find the LCM, okay, the reciprocal for this and find the LCM is going to be x2 equal to, this times this will give us 2. 1 into 2 is 2 times r will give us 2r plus 2 into 2, 1 times r will give us r. So we have 3r over 2. So our x2 for the square hole is going to be 3r over 2. Now, we can now determine the center of gravity for this combination. Now, because we have a situation, this square hole is being cut out from this circle, it means there is a hole here. We are not going to add, instead we'll subtract. And this is how our formula will look like. The x bar, the center of gravity, will be a1 x1 minus a2 x2 divided by a1 minus a2. We are subtracting because our a2, the shape in our a2 has been cut out from the original, the main circle. So that's why we are subtracting. This is actually a hole. So that's why we are subtracting a2 and the centroid from a1, and we're also subtracting the area. So whenever you have a situation whereby a shape is cut out from another shape, you subtract. That's the rule. So let's do this. Our a1 at this point, a1 is, okay, let me do this. So we have that. Our a1 is pi r squared, so we have pi r squared times our x1 is r, so we have r. This is minus our a2 is r squared over 2, we have r squared over 2 times, and our x2 is 3r over 2 all over our a1 is pi r squared minus our a2 is r square all over 2. So we've gotten to this point. We'll continue with the calculation. Okay, at this point you can say our x bar equal to pi r square times r square will give us pi r cube minus r square all over 2 times 3r over 2 will give us 3r cube all over 4, because this times this will give us 4, and r square times 3r square will give us 3r cube, and then we divide it by pi r square, which is this one, minus r square over 2. Okay, we can take it to this other end to continue our solution. So we have our x bar to be equal to, we can actually factorize from here. Since we have r cube here and r cube here, we can factorize. So we have r cube into, if we take out cube away from this point, it means we are going to be left with what? Pi minus r cube. From here we are going to be left with minus 3 over 4. So we divide it by, we also have r square here and r square here, so we can take it out. So when we take it out, we have r square into, what will be left here will be pi minus, and what will be left here will be 1 over 2. And then we continue that our bar will be equal to, this can cancel out. Okay, let me break out this. R cube is the same thing as saying r times r into pi minus 3 over 4 divided by r squared is the same thing as saying r times r into pi minus 1 over 2. And so this will cancel out this will cancel out this, so that our bar x will be equal to r into pi minus 3 over 4 divided by, okay, we are left with just pi minus 1 over 2. We can decide to further break this down to have that, okay, let me use here. So to have that x bar will be equal to r into pi minus, we say 3 divided by 4, it will give us 0.75 all over pi minus, we say 1 divided by 2 to give us 0.5. So this will be our centroid for that question. We are given the value of r, we can substitute it, and then we find the value of x in any unit that it might be. So basically that is how to determine the value of centroid for a circle with a square hole inside. It's very simple. Remember, whenever there is a hole or probably a particular shape has been carved out from another shape, you subtract, you don't add. Thank you.